Hello guys, welcome back to my channel. So today we'll be doing 5070 paper 2 variant 2 October November 2023. Okay, so the paper is of 80 marks and we have 1 hour and 45 minutes to solve it. So let's start with it. Okay. The first question. Choose from the list of compounds to answer these questions. Okay. We have this list of these list of compounds, and let's start with it. Okay. Each compound may be used once, more than once, or not at all. Identify the compound that part A is a waste gas from digestion in animals. So I guess it's very commonly heard. So I would write it as methane, and we do have an option. Yeah, methane. Okay, turns blue cobalt to chloride pink. So it would definitely be water. That okay, part C reacts with ethene above 100 degrees Celsius to produce ethanol. So it would be, steam, I guess. Steam. We don't have an option of steam, so I would just write water. And here we can see that it is being repeated, and we can repeat it as it is, written that we can do it. Part D is a product of photosynthesis. So what do we have here? Glucose, yeah. Glucose could be one. Glucose or oxygen. Glucose is here, so we write glucose. Contains an anion with a charge of -2. An anion, that means it should be a ionic compound. So let's see, do we have an ionic compound? No. Yes. Yes. No. 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 Yes. Okay. -2. We know that calcium has a +2 charge and it can have an anion with a -2 charge. Okay. So won't take sodium, we'll take magnesium. But as we write the formula MgO, and this would be MgCl2. We know that chlorine has a charge of -1 and magnesium has a charge of +2. So to balance it, we'll require two chlorines, which means that the anion has a charge of -1. But here, we know that oxygen has a charge of -2 and magnesium has a charge of +2. So I guess magnesium oxide is the correct one. So I'll write it here. Magnesium oxide. All right. Let's move towards the next question. The question is about metals. Okay. Chromium is a transition element. Sodium is an element in group 1 of the periodic table. State two physical properties of chromium that are different to those of sodium. Okay. So we know we have these two metals. One is a transition metal and one is a metal from a group 1. Okay. So the difference is that you know that well, I don't think so that um, this idea would be higher, higher than the level. But so sorry. So yeah, I could just simply write that you know, mm, uh, chromium, chromium has higher density. And chromium has a higher melting point. Let me just, just tell you the point that these two properties are due to greater number of electrons, free electrons, I must say, delocalized electrons, and the size of ion This causes the increase in melting point and density. Okay, so let's move towards part B. Reduce the number of protons and neutrons in the chromium atom shown. Okay, so the protons are simply this number 24, and for neutrons, what we'll do, we'll subtract 53 minus 24, so that would give us 29. Okay, so let's move towards the next question. Chromium 3 oxide reacts with carbon and chlorine to produce chromium 3 chloride, CrCl3, and carbon monoxide. Construct the symbol equation for this reaction. First, you write chromium 3 oxide and reacts with carbon and chlorine. And write carbon, chlorine. I'll leave some space so I could, write the numbers for balancing if required. Chlorine reacting with chromium 3 chloride. CrCl3 and carbon monoxide. Okay, so we can see that CrCl3 has no oxygen, and this means that all the oxygens are present in carbon monoxide, and here we can see that we have 3 oxygens, which means that we'll be having 3 oxygens here as well. For that, we need to put a 3 here as well, so let me do that. 3. All right, this is balanced now, and we have 2 chromium, so we'll add 2 here. We have 2 chromium here, so to balance it, we'll add 2 here, and this would make 2 through the 6, so I'll add 3 here. So okay, do that. 2 and 3 here. Complete the diagram with figure 2.1 to show the electronic configuration of a sodium ion, include the charge on the ion. We know that sodium is a metal, and it forms a cation by losing 1 electron, so the charge would be +1, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Party table 2.1 shows the observations made when 4 different metals are heated in oxygen. Put the 4 metals in order of their reactivity. Put the least reactive metal first. Okay. So lanthanum forms a layer of oxide rapidly on the surface but does not burn. So I believe, okay, let's first read all of the side. Mercury does not form a layer of oxide on the surface. Okay. Nickel forms a layer of oxide slowly on the surface but does not burn. Okay. Sodium burns rapidly. So burns rapidly means that sodium would be the most reactive. So I'll write sodium first because I figured it out first. Then I may say I'll just cancel it out. So the next I would go for let's see nickel. But it does not burn. Forms a layer of oxide slowly. You see it says slowly. Slowly. But here the same thing is happening, but it's happening rapidly. So lanthanum would be after would be before sodium. And I'll put nickel here. And last would be mercury remaining. I would write mercury here. All right. Let's move towards the next question. Aluminium is used in food containers and overhead electrical cables because it is resistant to corrosion. Part 1, explain why aluminium is resistant to corrosion. Okay, so we know that aluminium, it forms an oxide layer. So I'll just write that. It's for 2 marks, so I have to write 2 points. So it forms a layer of oxide and prevents. You know that corrosion happens due to, when oxygen gets in contact with the metal. So it prevents oxygen could be oxygen or water. Okay, so oxygen and water. Corrosion is basically like you might not know. We can't say that. Sorry, a sort of frosting. So we can't say that. And prevents oxygen and water, or you can say any damage causing material to get, we won't write damage causing, we have to specify, right? So, or I would say, let's just write water getting contact. So basically, corrosion happens, when oxygen and water gets in contact, and well, this mostly we can say rusting, because if when we are saying water and oxygen, so it's basically supporting resting. So well, here it's corrosion, so I just write corrosion in contact with metal. State the 2 other reasons why aluminum is used in overhead electrical cables. Because of its low density, because it is lightweight and has high electrical conductivity, because it is a metal. Okay, so let's move towards the next question. All right, it's a graph question. Okay, let me start it. A student investigates the reaction of large pieces of calcium carbonate with dilute HCl at 25 degrees Celsius. The hydrochloric acid is hydrochloric acid is an excess. Let me highlight it. All right. Complete the equation for this reaction by just adding state symbols. Okay, we know that all carbonates are solids, so red solid here. We know HCl is aqueous. Calcium chloride is aqueous, already given. H2 is liquid. And we are done with it. Okay. So part B. Figure 3.1 shows the volume of carbon dioxide gas released as the reaction proceeds. Okay. Reduce the volume of carbon dioxide gas released after 40 seconds. After 40 seconds. Here is we have time, and the x-axis is time. This is for time, and here we have 40. Okay, let me draw a line. Bring red to the y-axis. So here we have I have the carbon dioxide there, the y-axis, So here I have 30, 32, 33, 34. So each box is equal to 1 centimeter cube. So line touches at 1, 2, 3, 4. So it would be 34 centimeter cube. So let me write it here. 34 centimeter cube. Okay. The student repeats the experiment using the same mass of smaller pieces of calcium carbonate. Okay, so it's basically the rate of reaction question. All other conditions stay the same. Draw a line on the grade in figure 3.1 to show how the volume of carbon dioxide changes and smaller pieces of calcium carbonate are used. All right. Okay, so basically, what we have to do that the amount of calcium carbonate is the same, which means that the amount of carbon dioxide would be the same. But as it is in smaller pieces, so due to a larger surface area, the rate of reaction would increase. Okay, so let me draw a graph for that. So that means that the rate of reaction is shown by the gradient, okay, the initial gradient. So the initial gradient, let me erase this line first. The initial gradient would be steeper. However, the final volume would be the same. So let me zoom and draw it there. So I would draw it like how I could draw it again. So might be not accurate enough, but I'll try my best. Sorry. Just like now I'm just telling you it verbally that let me highlight it for you that here from here this part would be steeper than this one, okay? The highlighted part would be steeper than this black line, and this yellow highlighted part would show the final volume, and it would be equal to the initial the volume initially drawn graph, which means that here it is around 46. This 46 centimeter cube, so final volume would be the same as 46 centimeter cube. Check it like this. It's like it isn't accurate, sorry, but yeah, trying our level best to get as accurate as possible. There is 41, 42, 43, 44, 45, 46, 46. So yeah, we have to draw it like that. I wasn't able to draw it accurately as I was drawing it, digitally. So one we have 2 marks. So 1 mark would be for the steeper initial gradient, and 1 mark would be for that the final volume would be at 46. And let me tell you once again that the initially drawn graph drawn graph shows 46 centimeter cube as the final volume, and the newly drawn graph would also show 46 centimeter cube as the final volume, because the quantity, the amount, the mass, whatever you want to say, of calcium carbonate is the same, only the surface area has been changed. Okay, so next part. The student repeats the same experiment at 20 degrees Celsius. All other conditions stay same. Describe and explain how, using collision theory, how the rate of reaction differs when temperature 20 degrees Celsius is reached. What was the initial temperature? It was 25, which means that the temperature has been decreased. Temperature, as the temperature has been decreased, so the rate of reaction would also decrease. So I must write that rate of reaction decreases because particles have lesser kinetic energy due to which fewer successful collisions takes place. All right. Okay, part G. A sample of carbon dioxide is put into a gas range. The end of the gas range is then blocked so that no gas can escape. Explain using which by increasing the pressure of the gas range decreases the volume and the temperature stays the same. Okay, so they are basically asking that using the kinetic particle theory by increasing the pressure uh, uh, in the gas range decreases the volume of the gas. Basically, let me diagrammatically explain to you. Space. For example, let's suppose a gas range here. You can draw the gas range first. And from here, let's suppose this is the open end from where CO2 is entering. Okay, so let's suppose that it is filled with CO2, right? What is it? The question is telling us that. So let's suppose that here we have CO2 all over here, okay? And when we move this, when we decrease the volume, and when we, so what I'll do, move the plunger to the left side, due to which the volume would decrease. Let me show you how. I'll just show like, I just cover it with this, which means that the plunger is now, it's now here like this. Okay. So yeah, what will happen? Let's assume that the plunger is here. Okay, this whole thing is like this. So what it shows that, firstly the gas was in this whole area, like in this big area. But now, as I have shifted the plunger to the left, the volume, the area it was present in has decreased. The volume has decreased, not area. I should use it isn't appropriate. I should use volume. So the volume has decreased, right? Now it's like in this particular area, this area has vanished. So first it was in this area, now it is, sorry, my bad. Why I'm using area again? Sorry. First it was in this, it was covering this volume, then it covered half of it, then quarter, then much smaller. So what is happening? The pressure, I'm exerting the pressure on the plunger, and I'm exerting the pressure here, due to which it moves to the left and the volume decreases. So basically, what happens that first, for example, the carbon dioxide particles are arranged like this. Then when they are in this much volume, so what happens? They are like more closer, right? And then quarter of it, so they are more closer. And more smaller, more closer. That means that the particles are pushed closer together. So I write the particles are pushed closer. I hope I was able to explain it. And then for question number 3. So that's it for today. And I hope you were able to understand and you got everything which I tried to explain to you. And if you still have any question, any query, anything, then let me know down in the comments. And do like, share, and subscribe my channel. Till then, have a good time. Bye bye.